Good day to all of you students. In this video, we have to understand the sign convention regarding object distance, image distance, focal length of mirror, radius of curvature of mirror, height of object, height of image, when they are to be taken positive and when they are to be taken negative. That we have to understand very nicely so that we don't make mistake in numericals. So you have to understand first the concepts regarding when a certain quantity is to be taken positive and when it is to be taken negative. So children, what we'll do is, whether it's a convex mirror or whether it's a concave mirror. About lens we will talk later on. Right now I'm talking about mirrors, curved mirrors, concave or convex. So you know, this is my concave mirror. If I make it rough from this side and if I polish from this side, it becomes a case of concave mirror. That you already know. This becomes the pole. This is the principal axis. So I write P over here. This is the principal axis. Supposedly this is focus and this is center of curvature. This length is called focal length. The distance of focus from P, that is focal length, and this distance is called capital R, the radius of curvature. Distance of C from P. In the previous video, I have already explained what is center of curvature, what is focus, what is pole. All those things you already know. So now children, you know that object is to be always kept in front of mirror, on the polished side. We won't keep mirror behind the mirror. When you want to see yourself in the mirror, where do you stand? In the front of mirror or you stand behind the mirror? Naturally, in front of mirror. So object will be always over here, in front of mirror anywhere. It can be placed anywhere. So supposedly I am placing my object over here. It can be anywhere, again I am repeating. And we will understand children that object is always kept upright. We will assume that object is always upright, it is never inverted. We will always assume that. Okay, the object is kept upright, erect, in front of mirror. Then this object distance from P, this will be called U. U for object distance. And image can be formed anywhere. Supposing image is formed over here. Image. So distance of image point from the pole, this will be called V. So U will be object distance, V will be image distance, small f will be the focal length, capital R will be the radius of curvature. And if image is formed like this, you already know when I keep object between C and F, image is formed beyond F and it will be inverted, that we know. So this height of object will be called HO and height of image will be called HI. So you know what is HO, height of object. HI means height of image, U means object distance, V means image distance, small f means focal length, capital R means radius of curvature. These many things are there. Now children, what we will do is, at class 10th level, we will always think that incident rays are going in this direction. Means, concave mirror in class 10, you will never draw like this. Never draw concave mirror like this and never think that the shiny side is on this side. Never do that. Always think that polished side is facing this side and therefore object will be kept over here. So incident rays will go like this. Incident rays will travel like this. And this will be considered as positive X, the principal axis. This side is positive X, so incident rays will always travel in positive X. So never draw concave mirror in this direction. At class 10th level, in 12th you can do like this, that is okay. But at class 10th level, we will go according to the sign convention established by NCERT for class 10. So therefore I am stressing on the fact that always keep polished side of the mirror, whether concave or convex, facing negative x-axis. And therefore object will be there, so incident rays will always travel in positive x direction. So you have to make the mirror in such a way that incident rays always travel from left to right. Please understand nicely what I am saying. You will not make polished side facing positive x. See, this is the positive x and this is negative x. If you keep polished side this side, then if you keep object over here, the incident rays will go like this. they are traveling in negative x direction. Don't do this type of image. Don't draw this type of thing. You will only have that type of situation. So when we have that type of situation, our incident rays will always travel in the positive x direction. Okay, we will never have this type of thing. Even if it is a case of convex mirror, so we will have convex mirror like this. This will be the rough side, this will be the polished side, this will be positive x. We will think like this. So object will be always in the front of the polished side. So this is the case of convex mirror. So how you have to draw convex mirror, please understand. Polished side of mirror should be always facing negative x, so that incident rays always travel towards positive direction. Please understand nicely what I am trying again and again. Please write down in your books. The polished side of mirror should be always facing negative x, so that incident rays from the object always move in positive x direction. This situation or this situation. Right now I am running out this, I don't need this margin for rough calculation. Okay. So children, you know that in case of convex mirror, this is the portion of sphere from which the mirror has been cut. So center of curvature will be somewhere over here and focus will be somewhere over here. This will be the pole, this will be your focal length, this will be your radius of curvature. Here is the object, so this will be from the pole to this will be u. And you already know image will be somewhere over here. This is the image point, so this will be V. This will be HO, height of object. Okay, and this will be HI, height of image. So again, 6 things you have taken over here. Focal length, radius of curvature, object distance, image distance, HO and HI. We think like this. So I am forbidding you in class 10 to draw mirror in such a way that the polished side faces positive x. Don't do that. Polished side of the mirror should always face negative x, and object is to be always kept in front of mirror. So rays, incident rays from the object will travel in the positive x direction. We think like this. Whether it is this case or that case. This is convex mirror, I have written. Now children, what you have to think? The direction of incident rays you consider as positive. So first guidelines. First is polished side of mirror should always face negative x-axis. Okay, then object always kept in front of mirror. This will be the case for real object, because in class 10 you will be dealing only with real objects. Now, what do I mean by real object? You may think, sir, can there be a virtual object? Yes, there can be a virtual object. I will just tell you in brief how a virtual object can be there. See children, we saw how to form the image with the help of plane mirror. Supposing this is a plane mirror. Here is the real object, and you know its image will be here. And I told you, if I hold this object in front of mirror, image will be formed behind the mirror. Supposing this is the pen over here, its image will be formed over here. When I look into the mirror, I can see this image, I can see this pen. Yes or no? We can see ourselves and we can see the image of all the objects in this pen. We know this is a virtual image, children. This is the virtual image. It cannot be caught on screen. And our retina is also a sort of screen. So if this thing which is virtual, if it cannot be caught on screen, that means this image should not be formed on my retina. And therefore my brain should not be able to process anything, because this is not being formed on the retina, because this is a virtual image. Virtual image cannot be formed on the screen or the retina. But actually children, what happens? Our eyes are having lens. So this virtual image acts as virtual object for me, and then real image is formed on the retina. When you come to 12th, you will understand better. So this virtual image acts as virtual object for my eyes, and then real image is formed on the retina. Real image is formed, it is actually there on the retina. Therefore, my brain can process. So please understand the object. Now this virtual image became virtual object. So virtual object will be behind the mirror always, and real object will be always in the front of the mirror. So I am saying real object will be always kept in front of mirror. If it is a virtual object, it will be behind the mirror. In class 10, you don't have to worry on that about concept. Right now, you only think that all objects will be real only, so they will be in front of mirror. But when you come to class 12, you will realize that object can be behind the mirror also, and that is called a virtual object. So virtual object can form a real image. See, this virtual image became virtual object for my eyes, and this image is formed on my retina. So object which was not there, actually this image was not there, it was virtual. Still, its image was formed over here. So virtual image can act as virtual object, and then real image can be formed on the screen. That is what I am telling you. So right now, please understand that object will always kept in front of mirror. Object will be always upright. Will be always upright. Means object will be always erect like this, not like this. Okay. Then distance to be measured starting from pole. Starting from pole P. That means you have to go from P to O, you have to go from P to image, you have to go from P to F, you have to go from P to C. That is what I am saying. So distance to be measured always starting from the pole. If I want to know what is the focal length, I will not go in this direction, I will move in this direction. If I want to know what is object distance, I will not go like this, I will come like this. From pole you have to start measuring. From pole you have to go to focal length, from pole towards object, from pole towards center of curvature, from pole towards image, like this. We will never go like this, no. Sign is important, because in which direction I am moving, that is important. So please note the direction. Distance is to be measured always starting from pole, please keep in mind. Then distances above principal axis always positive, and distances are right over here. Distances below principal axis always negative. That means your object will be always above the principal axis because it is erect. Therefore, HO will be always positive. It means very clearly that HO will be always positive because we are assuming that object is kept erect. So HO can never be negative. Height of object, that can never be negative. When I talk of this, distance to be measured starting from pole always. So you have to observe that if I go to focal length from pole, my incident rays are going like this. So if I move in direction of incident rays, my distance will be positive. If I move against the incident rays, my distance will be negative. So distance is positive if you move in direction of incident rays, and negative if you move opposite to incident rays. Like this we think. So distance is positive if you move in direction of incident rays, and negative if you move opposite to incident rays. So these 5 to 6 things are there. Now please understand. My incident rays are going like this. I want to measure focal length. I go from P to F. I go like this. Incident rays going like this. I go like this. the focal length will be negative. The focal length is negative for a concave mirror always. If I go to center of curvature from pole, I move like this. Incident rays are going like this, I move like this. I am moving in opposite direction because I have to always start from here only. I move like this. Therefore, radius of curvature will be always less than 0. It cannot be positive for a concave mirror. Object distance, I said object always in front of mirror. Object distance always negative. Image distance, if image is formed over here, real image, it will be formed in front of mirror. Then it will be negative. So V will be negative if it is real, and V will be positive if it is virtual. You know, children, you know that when we keep object over here, image is formed over here. In that case, from P to I will go like this. From P, because I always begin from P. So if the object is kept between P and F, so I know image will be here. So I will move from P to I in this direction, in direction of incident rays. So my V image distance will become positive. So U less than 0, I write for that also. U less than 0 for real object and U greater than 0 for virtual. Though you may not worry about this thing right now. But anyway, U greater than 0 means object will be here behind the mirror. V will be negative, image on this side, see I go like this. So V negative for real and V greater than 0 behind the mirror, it will be virtual. So this is for concave mirror. Let us think for convex mirror. The object is kept over here, incident ray is going in this direction. I want to know the focal length. I start from here and go to F. I am moving like this in right side. Incident is also in the right side direction. So what will be the focal length? It will be positive. I am talking of convex mirror. What about radius of curvature? From P to C I have to go. From P to C, I am moving like this. I am moving in right side. Incident is also in right side, and therefore R will be greater than 0. For a convex mirror. Understand why? U, as I said, U will be less than 0. Object from pole to like this I go. Opposite direction of incident rays. U will be greater than 0, less than 0 for real, and U greater than 0 for virtual. And same thing for V. V will be less than 0. The image will be formed over here if it is real. If at all it is real, that you will see in 12th, and V will be greater than 0 if it is virtual. Image and object behind the mirror, they are virtual and they will have positive sign. Image and object, if they are negative, they are in front of mirror, they will be real. So these are about the concepts of convex mirror and these are concave mirror. In both the mirrors, remember, object and image in front of mirror, they will be negative, they will be real. Object and image behind the mirror, they will have positive value, they will be virtual. You can write if you want. In either case of the mirror, if U and V are negative, that means they are in front of the mirror, they are real. If U and V are positive, they are behind the mirror, they are virtual. So you can pause and you can write this point. Again I am repeating for you. For concave mirror or convex mirror, if U and V are negative, that means they are in front of the mirror, they are real. If U and V are positive, they are behind the mirror, they are virtual. So remember, in concave mirror, focal length and radius of curvature will be negative. For convex mirror, F and R will be positive. That is the main difference between concave mirror and convex mirror. In concave, F and R will be negative. In convex, F and R will be positive. There is no need to memorize it in class, in your brains. For exam, you draw the diagram and you understand what is happening. If you go with the incident ray, it is positive. If you go against the incident ray, it is negative. Draw diagrams and understand. These points I have written for you. Please pause and copy, children. Please pause and copy. Children, you understood so far the sign convention for object distance, image distance, height of object, height of image, focal length and radius of curvature in case of concave and convex mirror. Let us move further. What is the relation between object distance, image distance and focal length in case of curved mirrors? So whether it is a case of convex mirror or concave mirror, please remember 1 upon u plus 1 upon v will be 1 upon f. This relation is true for both the types of mirror, that is first formula. 1 upon u plus 1 upon v equal to 1 upon f, and the values of u, v and f are to be taken with proper sign convention which I told you. Whatever is to be found out, supposing v and f is given to you and you are told to find u. Now as you all know children, that u will be always negative because object will be always in front of the mirror. So you know that u is negative, but when you have to find out u, don't write it as minus u. Keep it as u only, automatically it will come out to be negative. Or if you have to find v or if you have to find f, supposing concave mirror is given to you, you know that concave mirror focal length is negative. So if u and v are given and you are asked to find f, so don't put minus f in the formula. So whatever thing is to be found out, we don't put its proper sign, we keep it as it is, and automatically we will get the proper sign at the end of the question. So in spite of knowing that it's a concave mirror and its focal length is always negative, don't write minus f in the formula. Formula will remain this only. Put the values of u and v with appropriate sign if their values are given, then find out f, it will come out to be negative if it is the case of concave mirror. Similarly, if v and f are given, you are asked to find u, so you know that object distance is always negative whether concave or convex mirror. So don't write minus u, keep it as u only. So whatever things are to be found out, their signs are not inserted beforehand. You keep them as they are, and finally you will get the correct answer with the correct sign automatically. Okay, so that thing is clear. What will be magnification? Magnification will be HO upon HI, HI upon HO, height of image upon height of object. This will be the magnification. Now HI and HO to be taken with proper sign when you want to find magnification. HO, we understood that object is always erect. So HO will never be negative. HO will be always positive. Because we assume that object will be always kept upright before the mirror. Kept erect. Upright or erect, one and the same thing. What about image? If image is erect, then take it positive. If image is inverted, take it negative. So what HI and HO? When to take plus, when to take minus. HO always positive, HI accordingly whatever is the situation. One more formula for M is there, that is minus V upon U. And V and U with appropriate signs. Whatever you get, plus, minus, whatever, you get the value of M. So these are the three formulae for mirrors. 1 upon U plus 1 upon V equal to 1 upon F. This is called mirror equation. Magnification formula HI upon HO, and that is also equal to minus of V upon U. Please copy and then we see how to take V and U negative or positive. Please pause and copy these three formulae. Okay. Now see children, we have already drawn the images of concave mirror. Let us redraw them again. So I will not draw the entire images, I will just keep in mind, and that you should keep in mind children, very important. You know that when object was kept beyond C, image was formed somewhere between C and F, that we know already. So this much is F, here is the object, incident rays will go like this, that I told you already. We are talking of concave mirror. So rays are going like this, always they will move towards right side. The polished side should be always on the negative X side. So if I want object distance, that is negative. Image distance, negative. HO will be always positive. We know whenever the image will be formed, it will be inverted. You can go and see your diagrams. So HI will be negative. Okay? If I calculate M equal to HI upon HO. So this is minus, this is plus. Minus upon plus, it will be a negative ratio. If I calculate by the formula minus V upon U, See, V and U both are negative. So minus upon minus becomes plus. Minus upon minus becomes plus, and this one more minus. It will also be less than 0. ठीक है? Okay. Then this one we have taken. If I keep on center of curvature, the object is here only. This was focal length. Image was found here only, if you remember, at the same point. So this way the incident rays go. This is my concave mirror. So I can make out that U will be less than 0, V will be less than 0. Object and image distance. HO is positive. HI will be negative because it is an inverted image. So here you can see M will be HI upon HO, that will be negative. Negative upon positive. And if I take by the formula minus V upon U, both are negative, minus 1 minus plus, so this also will be less than 0. M, if you find out by any formula, they will come out to be same. So I am teaching you when to be taken positive, when to be taken negative, that I am explaining to you. Then we kept, this is the concave mirror, this was F, this was C. We kept between C and F the object. This was the object. Incident ray is going like this. An image was found beyond C, that you know. So this was the image point. So I can make out that U will be less than 0. V also less than 0. From pole, like I move like this. This is the pole. Okay. So U and V less than 0. HO is positive. HI is negative. So what about M? HI upon HO. What about by the formula of minus V upon U? V and U both negative, that also less than 0. Then you not keep on focal length, because if you keep on focus, the image will be at infinity. So we don't consider that option. Now between F and P, okay, this is the rough side. I know if I keep my object over here, incident ray is going like this. This is the object. Image will be found over here. So incident ray is going like this. U less than 0. For image I move like this. So V will be positive in this case. HO, it is positive. This is HI. HI is positive in this case because image is erect. See, erect image is found when we give object between focus and goal, that you have studied. So M from here, HI upon HO, plus upon plus. And magnification from the formula minus V upon U. V upon U, this will be negative because minus upon plus. And then one more minus, so it becomes positive. Please draw the diagram, children, so that you understand. When you have to take HI positive, when you have to take HO negative, when you have to take U negative, when you have to take V positive. U, of course, negative in all the cases. In one case, V is becoming positive. Please pause and copy, children. Now let us discuss sign convention of convex mirror, children. I told you that polished side always will be on the negative x. So if this is my axis, positive x and negative x, the mirror should be like this. This is the polished side always facing the negative x. This is the case of convex mirror. This will be the sphere from which the mirror is cut. So focus will be here and center of curvature will be here. This will be the pole. Object will be always kept in front of mirror. This will be object. So incident rays will go like this, always moving from left to right. And you know, image is always found between P and F in case of convex mirror. You know the ray diagrams. So this is the image point. So children, if I talk about U, this is U for me. And this is V for me. From here. So this one distance is V and this much is U. From here to F and then C. So we know that U is less than 0 and V is always positive. This is HO and this is HI. I can make out that HO is positive, as usual, always positive. And here HI is also positive. Always in case of convex mirror, image will be always erect between pole and focus. We have seen in the case of ray diagrams. Wherever you keep the object, image will be only here only and it will be erect. Okay. So what about the magnification in this case? Hi upon HO. Hi also positive, HO also positive. So this will be positive. If I go by the formula minus V upon U, look at V and U. This is positive and negative. This ratio will be negative. Negative and minus, it will become positive. Now about the nature of image, children. Nature of image. See, first is whether image is real or inverted. That is the first comment you have to make. Whether image is real or inverted. Third, it is real or virtual. Please, real or virtual. Then erect or inverted. Erect or inverted. And then finally, diminished. Diminished means small in size or enlarged. So three things you will have to write in exam. Your image is real or virtual, anyone. Erect or inverted, anyone. Diminished or enlarged, anyone. How to decide? You know that, children, I told you, image will be real if V comes out to be negative. In front of mirror, image is real. And behind the mirror, it is virtual. To look at the sign of V. If V is positive, image is virtual. If V is less than 0, image is real. About erect and inverted. Image will be given by HI. So if it is erect, HI will be positive. And if it is inverted, HI will be less than 0. Now how can we get the value of HI and HO? How can we identify whether it is positive or negative? So children, look for M. M is equal to HI upon HO. HO is always positive, children, because object is always erect. So whatever is the sign of M, that will be the sign of HI. So if M is negative, HI will be negative. So look for M. What is the sign of M? So M negative means HI negative. And M positive means HI positive. So sign of M will tell me erect or inverted. Sign of M. From there you can get sign of HI also, because they are having same sign. I told you from here. HO will be always positive. So forget about HO. If M is negative, HI will be negative. If M is positive, HI will be positive. So from the sign of M, you have to tell whether image is erect or inverted. And diminished or enlarged. See, if the image is enlarged, that means HI will be more than HO. If image is enlarged, the height of image will be more than height of HO. So this ratio will become more than 1, because HI is more, HO is less. So if it is diminished, modulus M, not M, modulus M, because M can be negative also. Get its small magnitude. If it is minus half, look at the value of half. If it is minus 3, look at 3. If mod M is less than 1, then it is diminished. And if modulus of M is more than 1, then it is enlarged. So how you have to decide whether your image is enlarged or diminished, real or virtual, erect or inverted? These many ideas are given you. You have to follow these ideas and then you have to do the sums. So children, in this video we have seen what are the sign convention for concave mirror and convex mirror, particularly for their focal length and radius of curvature. For convex mirror, focal length and radius of curvature, they will be positive, moving in direction of incident rays. For concave, they will be negative. I told you real object always in front of mirror, so U always less than 0. If object is in front of mirror, image is in front of mirror, so V will be negative. If image is behind the mirror, V will be positive. And then what are the formulae for magnification and all those things I told you for convex and concave. Please keep them in mind. And then in the next video, we will take up some sums. Thank you, children. God bless you.